Hey everybody, time for another video, and this time we are going to be using Kc again to solve equilibrium concentrations, but have I got a doozy of a problem for you this time, because we are going to use the balanced chemical equation CH4 is in a reversible reaction with C2H2 as well as 3 hydrogens. Try not to cringe, try not to worry, but you're seeing that 3 and you know what's coming down. And we tell you that at some temperature we have a Kc value equal to 12, and you've been given a flask. And in this flask we have placed a concentration of methane equal to 1.5 molar. So this is our initial. These are our initial values. They are what we are putting into the flask to get started. And our C2H2 is going to be 0.4 molar. And our concentration of H2 is going to equal 0.2 molar. Now these are not equilibrium concentrations. These are just the concentrations that we happen to throw into a flask. You throw these into a flask, you go grab your dog, you go to the park, you play, you have fun, you catch the frisbee, they catch the frisbee, and then you walk back home and you check and see what happened in your flask. While this reaction took place, how many times did it take place? We don't know. That's what we're going to find out. It's going to take place X times. Because this reaction took place X times while you were out walking and playing with the dog and catching frisbees, we have to figure out what our changes were. Well, if the reaction happened X times, and every time we do the reaction we lose 2 methane, the change would be minus 2x. And if we did this reaction X times, every time we do it, we gain 1 C2H2, so it would be plus X. And oh, this hydrogen, I see it coming. Every time we do this reaction, we gain 3 hydrogens, so if we do it X times, it will be plus 3X. So we can say that our equilibrium concentrations, the ice table, initial, change, equilibrium, for the CH4 will be 1.5 minus 2x, and for the C2H2 it will be 0.4 plus x, and for the hydrogen it will be 0.2 plus 3x. And we can create our Kc expression. Our Kc expression is going to be Kc is equal to our products, C2H2, it has no coefficient, so, well, it has a coefficient of 1, so it has a power of 1, and our concentration of our other product, hydrogen, it has an exponent of 3, and this is all over our reactant, CH4, which will have an exponent of 2. Great. Time to solve what these equilibrium concentrations are going to be. Once we have our equilibrium expression, we must fill in our equilibrium values. We know our Kc. That's a 12. It's going to equal our concentration of C2H2. That's 0.4 plus x multiplied by our concentration of hydrogen. That's 0.2 plus 3x cubed. I'm so excited, I love it. And the methane, CH4, is going to be 1.5 minus 2x squared. And you say, why did you do this to us? This isn't a quadratic. How are we supposed to solve this? But I believe in you. I believe in you. We're going to rearrange this just a little bit. I want this denominator brought up. So it's going to be 12 multiplied by 1.5 minus 2x squared. And that's equal to 0.4 plus x multiplied by 0.2 plus 3x cubed. All right. I am not going to do synthetic division or anything to try and solve this for x. We are going to do some shenanigans. Because what we are going to do is bring all of this on the left over to the right-hand side. And yeah, we probably could have done it up here one step, but I kind of like the way this looks better, and it makes me happier about to put it in a graphing calculator. So I'm going to subtract both sides by this 12 multiplied by 1.5 minus 2x squared, and it's going to leave us with 0 equals 0.4 plus x multiplied by 0.2 plus 3x cubed, subtract 12 multiplied by 1.5 minus 2x squared. At this point, this is some graph. Yeah, it's a quartic. It's a quartic. If we expanded this out and simplified it, we're going to get a quartic, and you can do that. But there's another way. If you solve this function, put it into a graph, and get the x-intercepts, that will be your answer. So that's what I went ahead and did. I plugged this into a graphing calculator, and check out what the graph is going to look like. Ooh. So all we do is put this in. You can use any graphing calculator that you have. And now we need to find the x-intercepts. We know it has to be a positive answer. It can't be negative, which means it has to be this x-intercept right here, which is 0.4726. 0.4726. So we can get this answer simply by graphing our function and finding the x-intercept, whether it's a quadratic or a cubic or a quartic, and this works on the easy ones as well as the hard ones. So let's write that down. Our x solved graphically, we know that's our x value, we've solved it graphically, is 0.4726, which means our concentration of methane, which was 1.5 minus 2x, is now going to equal 0.5548 molar. Our concentration of C2H2 is going to equal 0.4 plus x, so it's going to be 0.8726 molar. We just take this x value and fill it into the equilibrium concentrations. We got those from the ice table up above. And our hydrogen, that cubic that totally messed us up, is still going to be 0.2 plus 3x, which equals 1.6178 molar. And that, my clever little cupcakes, is how you can use a little bit of graphing technology to quickly solve these KC questions without having to worry about doing all the algebra. I hope this was a big help, and I'm looking forward to seeing everybody next time. Cheers!